Okay, this segment is just multiplication of complex numbers in rectangular form. So what I have here in number 7 is a monomial, a negative j, times a monomial, negative 4j, times a monomial, 9j. Remember, this one has a negative 1 in front. These are just monomials, so I can write these in any order. So essentially, I want to take the negative 1 times the negative 4 times the 9, and then this j times this j times this j, which will give me j to the third power. So out in front, a negative times a negative is a positive, and 4 times 9 is 36. So I have 36j cubed, but remember, j cubed is equal to a negative j. So careful, that's 36 times a negative j, or I'm going to write that as a negative 36j. So I'm simplifying these expressions, but the process is multiplication that I'm doing. Here I have a monomial, 3j times, so square root of a negative 9 is 3j, times 3 minus 2j. And just like, if you don't mind, I'm going to come on over here. Just like when I distribute 2 times 3x plus 5, and 2 times 3x is 6x, and 2 times 5 is a positive 10, I'm going to do the same thing here. So 3j times 3 is 9j. And 3j times a minus 2j is a minus 6j squared. But please remember, j squared is equal to a negative 1. So you have there a minus 6 times a negative 1, which is a positive 6. So 9j plus 6. Many people will write this real number first and then imaginary number second. Addition is commutative. I don't care what you do, but I want you to know that you'll often see the 6 before the 9j. All right. So always remember j squared is a negative 1. And from now on, like when I saw this minus 6j squared right there, when I saw that minus 6j squared, from now on I'm just going to call it a plus 6. I'm going to drop the j squared off because I take that negative 1 and change the sign of this because a negative times a negative is a positive. Now, number 9, 10, and quite a few that follow are foiling algebraically. So let me remind you, 2x plus 3 times 3x minus 5, I just picked two binomials off the top of my head, is 6x squared minus 10x plus 9x minus 15. And often the middle terms are like terms and you should combine them. A negative 10 and a positive 9 is a negative 1x. You don't need that negative 1, of course. You just need the minus sign. And you have this trinomial. That's what we're going to do here now. We're just going to FOIL. So 2 times 3 is 6. 2 times a negative 5 is a negative 10j. 3j times 3 is a positive 9j. And 3j times a minus 5j is a minus 15j squared. So the only difference between this and this problem over here, this is the same. These will combine to be a negative 1j. But see the minus 15j squared? Remember, I'm just going to cross that off and make that a plus 15. It's a number now to be added to the 6 up front. So 6 and 15 combine to be 21, and then I have 21 minus that 1j. Okay, let's just keep going, and then we're going to notice something unusual after this question. So this is 7 minus 4j, and this is a negative 2 minus 9j. And I'm going to do this fairly quickly. So that product is a negative 14. That product is a negative 63j. This negative times a negative is a positive 8j. And this negative times a negative is a positive 36j squared. But I'm going to cross that off and think of it as a negative 36 so that I can combine it with the negative 14, because those are going to be like terms. So they add to be a negative 50. And then these middle terms right here combine to be a minus 55j. And I'm all done. All right, check out what happens when you multiply a complex number by its conjugate. Do you remember in the last unit, if this was a plus sign, the conjugate had a change of sign in front of the imaginary piece. Watch what happens. 4 times 4, 16. Here I get a negative 20j. Here I get a positive 20j. j, and 5j times a minus 5j is a minus 25j squared. But remember, a minus 25j squared becomes a plus 25, and I combine that with the 16. So that adds to be 41. But when you multiply a complex number times its conjugate, these two terms disappear because one was a minus 20j, the other was a positive 20j. That's 0j, which you do not need to write. So multiplying a complex number by its conjugate gives you an answer that is just a real number all the time. Here's one more. Check it out. So this is a complex number, and then notice the next binomial just has, instead of a minus sign here, a plus sign here. Notice these are conjugates. Negative times a negative is a positive 9. Negative 3 times j is a negative 3j. Negative times a negative is a positive. See, those are always going to cancel out because they're opposite in sign. And a negative times a positive is a minus j squared. Careful, that one's a little bit hard because that's a minus and this is equal to a negative 1. So you got minus a negative 1, which means plus 1, and you have the 9 out front here, which adds to be 10. That's the answer to this problem because these two cancel out because they're a negative 3j and a positive 3j. Let's do a few more multiplications, and then we're going to try division in our next segment. When you see a binomial squared, I'm not going to do the work to this one. I just want you to know that you should remember to write this out twice and then go ahead and FOIL it. I have my notes here, and I'm just going to tell you, if you would work that one out, that when you FOIL it, you'll get a negative 5 minus 12j. This next one has binomial, and then it wants you to subtract a binomial squared. So order of operations says that you need to square that binomial first. So let's do 2 minus j times 2 minus j, and we'll apply this negative sign when we're done because it belongs to all of it. I'm not going to worry about this yet. So I've got to FOIL this. So 2 times 2 is 4. 2 times a minus j is a minus 2j. A minus j times 2 is another minus 2j. These are not conjugates. And a minus j times a minus j is a positive j squared. So I have this 4, and this is a minus 1. These two combine to be a minus 4j. And the 4 minus 1 is 3. Bring down the minus 4j. And now I need to subtract. I'll bring down this other binomial. Now I need to subtract this. So I need to apply a negative 1 times both of these. I'm just going to come over here and copy this. So I have a negative 6 plus 2j. The 3 is going to become a minus 3, and the minus 4j is going to become a plus 4j. The real terms combine to be a minus 9, and the 2j and the 4j add to be 6j. Okay. I think I can get one more in here. This one's crazy looking, but if you think about this, j squared is equal to a negative 1. So that expression right there is just a negative 2. Then I have a minus 3 times j cubed, but j cubed is a negative j. So a negative times a negative would be a positive 3j for that term. Here I've got plus 2 times 1. Remember, j to the 4th is 1. And then minus 2, j to the 5th, which is a minus 2 times j, because j to the 5th is j to the 4th times j to the 1st. j to the 4th is 1. 1 times j is j. So that's a minus 2j. All of that needs to be squared, but I'm doing what's in the parentheses first. And I'd like you to notice that a negative 2 and a positive 2 adds to be 0. And then 3j minus 2j is just 1j. And then now I'm going to square that. That's so much easier. And finally, j to the 2nd power is j squared, and I get a negative 1. When we come back, we're going to finish the last operation, which is division.